So today we are going to discuss time rates, that is application of what we have discussed on the previous lessons. So time rates, that is a problem involving rates of change. So we have here the possible procedure, okay, the procedure in solving for time rates. So number one, that is draw a figure if it's feasible to do so. So because from the figure, you can visualize what formula and what you're going to do with the problem. Then after that one, define the variables. Generally, define time first because other variables usually depend on it. So we are going to define the formulas. When you say define the variables, that is you are going to determine what is changing and what is constant. Okay, that is important. Then number 3, write down any numerical facts known about the variables and their derivatives with respect to t. So, write down any numerical facts. So, you write down any given that can lead to your solution. Then, after that one, write an equation to relate the variables that depend on t. Okay. Based on the figure that you have drawn, you can write the equation based on that form. Okay. Number 5, differentiate. Okay. So, we are going to differentiate the formula that you have formulated. Differentiate with respect to t, both sides of the equation found in step 4 to relate the rates of change of the variable. Okay. Number 6, substitute values of known quantities in the equation of step 5 and solve for the desired quantity. Okay. So, that are the steps in solving for time rates. So, we have example to illustrate how to solve this one. Okay. Okay. So, our first example, that is a cylindrical tank with radius 5 centimeters is being filled with water at a rate of 3 cubic centimeter per minute. How fast is the height of the water increasing? Okay. So, problem states that a cylindrical tank with a radius of 5 centimeters is being filled with water at a rate of 3 cubic centimeters per minute. Okay, so let's try to illustrate. Water is getting inside at a rate of 3 cubic centimeter per minute. So as you notice, the height of the water is increasing, right? But then, if you are going to look at the container, the radius of the container is not changing. So for this problem, the radius is constant. What is changing is the amount of water inside. So the rate of the change here, that is the height of the water, is changing. So therefore, you are going to find the rate of change of the water, the height of the water inside. And then, as you can see, when there is a change in the height of water inside the container, there is a corresponding change of the volume of water inside. So, the change of the volume of water inside, that is what we called as dV dt. The change of the height of the water with respect to time inside the container, that is what we called as dH dt. Okay, so in finding for the formula of the volume of a cylindrical tank, that is volume, the formula that is equal to area of the base times height. So, if you are going to look at this one, the base of the cylindrical tank is a circle. So, therefore, volume that is equal to area of the base times height, the formula of a volume, therefore, that is equal to what is area of the base? That is a circle. So, therefore, the formula of area of a circle, that is pi r square. So therefore, the formula of a volume, that is equal to area of the base times height, which is area of the base is circle. So therefore, volume is equal to pi r square times height. Okay. So in our problem, the amount of water that is getting inside, that is equal to 3 cubic centimeter per minute. And then the radius is equal to, the radius of the container is equal to 5 centimeters. So what is changing in this problem? So as the amount of water is changing inside the container, so do with the height of the water inside. So we have here. So if you look at the height of the water, so at any rate of time, there is a change of the height of the water. And that is what we called as dH over dt. Okay. So we have here the figure. So we have a container with a radius of 5 centimeters. Okay. As the rate of water that is getting inside, that is what we call as dV dt, which is equal to 3 cubic centimeter per minute. As the water is getting inside the container, of course, the height of the water is increasing. And that is what we called as dH over dt. The change of height of water with respect to time. So that are only the given, radius and dV dt. And then we are going to find dH dt. That is the change of the height of the water at any time. Okay, to solve, so we have here a solution. So to solve, okay, let's review. Radius as our given, that is equal to 5 centimeters. dV dt, that is equal to 3 cubic centimeter per minute. Okay. And what is being asked here? dH over dt. Okay. So the figure, that is a cylindrical container. Then we have radius here, that is equal to 5. dH dt is being asked. And then the amount of water that is getting inside, that is dV dt. And that is equivalent to 3 centimeter per minute. Okay. So, to solve this one, let's start with the formula. The formula of the form of the water inside. So, the form of the water inside, that is still in cylindrical form. So, to find the volume of a cylinder, that is area of the base times height. So, the form of the base of the cylinder, that is a circle. So, the water inside the cylindrical form, that is in cylindrical form. Because that is in cylindrical form, the area, that is equal to pi r squared times height. Okay. So, therefore, the volume is equal to area of the base times height. Volume is equal to pi times height. Then, you are going to find the derivative, both sides, pi r squared times height. Okay. So, you will have dV dt equal to dV dt of pi r squared times height. So, if we are going to look at here, dV dt, that is equal to, okay, pi here is constant. Radius is constant, right? Because throughout the illustration class, when we are going to put water inside, the radius of water, that is not changing, right? It's only the height. So therefore, radius is constant. So radius is 5 centimeters. So therefore, you will have pi r square. Because that is constant, treat that one as constant. So therefore, you will have dh dt. So therefore, what is r equal to? That is equal to 5. Square of 5, that is 25. Okay? 25 pi dh dt. Where did I get 25? That is from radius square. 5 square. So therefore, dh dt, that is equal to dB over dt over 25 pi. And what is dV dt? dV dt is equal to 3 centimeter cube over per minute. So therefore, you will have 3 centimeter cube per minute divided by 25 pi. What is the unit of 25? That is centimeter square. So therefore, you can cancel centimeter square. So what remains is 3 over 25 pi, okay, unit centimeter per minute. And that is now our dh dt. So that is our final answer. Okay, so example here, our next example, that is a ladder 25 feet long is leaning against a vertical wall. If the bottom of the ladder is pulled horizontally away from the wall at 3 feet per second, how fast is the top of the ladder sliding down the wall when the bottom is 15 feet from the wall? Okay. So, we will solve this one. We will illustrate first so that you can picture out how does it go. Okay. The next example class, that is a ladder. Okay, we have here a ladder that is 25 feet long, is leaning against a vertical wall. So the vertical wall here, this one, kani siya mong vertical wall. This is your vertical wall. This is supposing your ladder. Okay, a ladder that is leaning against a vertical wall. If the ladder is being pulled horizontally, okay, if that is being pulled horizontally away from the wall, that is being pulled horizontally away from the wall at 3 feet per second, okay, 3 feet per second. How fast is the top of the ladder sliding down the wall when the bottom is 15 feet from the wall? Okay, it is being asked how fast. Okay, if you are going to pull the bottom of the ladder away from the wall 3 feet per second, okay, this is being pulled, then the ladder is sliding down. So the question is, how fast is the top of the ladder? Okay, so how fast is the top of the ladder sliding down? So if you're going to look at here, what can you relate? Okay, so this is now the form of the ladder. So if this is the form of the ladder, this is now in a form of right triangle, right? If that is a form of right triangle, this is now your hypotenuse. Your vertical wall of your ladder, that is your y. And then this one, the level this one, this is your x. So you have a form of x, y, and z. And your hypotenuse is your ladder. So if you are going to pull the bottom part of the ladder, of course, the top of the ladder is sliding down. Okay. The question is, unsa ka kusgon? Okay, how fast is the top of the ladder sliding down the wall? So what is changing here? So if you are going to look at what is changing, o try to observe what is changing. Of course, unsa may nag-change? Nag-change ang height of y, okay? Y is changing. There is the vertical height of y is changing. That is decreasing. And the x-axis is increasing. Of course, it is increasing. The x-axis is increasing. So, illustration here, the bottom part of the ladder is being pulled. So, therefore, x is increasing, y is decreasing. Okay. Okay, let's try to solve. So, solution, dx dt is equal to 3 feet per second. Dy dt is unknown. Okay, we are going to solve this one at the instant that x is equal to 15 feet. Illustration here, this one is your vertical wall. This is your horizontal ground. This one is your ladder, 25 feet. So, when we are going to pull the ladder horizontally at the bottom part, of course, the ladder will slide down. Okay, that is sliding down. Of course, the height of your y, vertical height of y, is decreasing. And then this horizontal x is increasing. So, since there is a change of the vertical height of y and the horizontal distance of x, so we are going to find the derivative of x with respect to time. Then we have here derivative of y with respect to time. From our illustration, we illustrate a while ago that is a form of right triangle. Because that is a form of right triangle, we are going to use Pythagorean theorem. So we have here x, y, and we have our diagonal, that is 25 feet. So by Pythagorean theorem, we have x squared plus y squared is equal to 25. Then we are going to find the derivative both sides with respect to the rate of time. So there you will have x squared plus y squared is equal to 25. So derivative for both sides, we will have derivative of x squared. We can find the derivative of x. Find the derivative of y because that is changing. While the ladder, that is not changing. So that is constant. So derivative of x squared, that is 2x. Derivative of y squared, that is 2y. Then 25, derivative of 25, that is equal to 0 because that is constant. So we have here derivative of x squared, that is 2x dx dt. Derivative of y squared, that is 2y dy dt equal to 0. So since 2 is common, that could be cancelled out. So x dx dt plus y dy dt equal to 0. We are solving for dy dt, right? So dy dt, y dy dt, transpose dx dt to the other side, that is positive. So when you are going to transpose, that would become negative. So negative x dx dt. So dy dt, that is equal to cross multiplication. So y, so that would become a denominator here. So dy dt is equal to negative x dx over y. So we are going to find dy dt when x is equal to 15. So when x is equal to 15, we can solve for the value of y. What is the value of y when x is equal to 15? So from the definition, this is now your equation. So we have x squared plus y squared is equal to 25. So if we are going to solve for y here, so y squared is equal to 25 minus x squared. So y is equal to the square root of 25 minus 15, right? Okay. So this is 25 square. Okay. So you can have here you can have here y is equal to the square root of, okay, y is equal to the square root of 25 square minus x square. So, 25 square, that is 625 minus 15 square. Then, you can have y is equal to 20. So, when we can solve for y, so we have now, therefore, x is equal to 15, y is equal to 20, dx dt is equal to 3. So, that are now your givens. So, substitute that one. dy dt is equal to negative x over y dx dt. Okay. So, substitute the value of x, substitute the value of y, substitute the value of dx dt. Then, you can now have the answer. The answer here, as you can see, you have negative 9 over 4. Negative, that denotes that y is decreasing. Okay? Okay. Thank you. Okay, kindly answer this one. Number 43 and number 44. So, try to practice. Please answer number 38 and to number 41. Okay? Thank you.